Okay, now the most important one, probably the most important one, or the most important concept of unit number one is uncertainties. So you might be asked to find percentage uncertainty or absolute uncertainty. Okay, there are mainly two possibility: percentage or absolute. So let's say you are provided with an expression that is written as or any formula. For example, t equals to 2 pi square root L over G. Okay, so you are provided with this formula. The question is find the percentage uncertainty of t, or the question is find the absolute uncertainty of t. How do we do this? First of all, the values would be given. For example, length equals to 10.0 centimeter plus minus 0.1 centimeter, and the value of g is given, let's say 9.81 plus minus 0.02 ms minus 2. So let's say this is the situation that we have. So you're required to find the percentage uncertainty of t. How do we find? Ignore all the coefficients. In your formula, you have length and you have g. You have two things which are being divided or multiplied. And then you have exponent also, which is square root, can also be written as raised to the power 1 over 2. So find the percentage of length, find the percentage of g, add both of them, and multiply the answer by whatever the exponent is. How do you find percentage of length? 0.1 divided by 10 multiplied by 100. No conversion needed for percentage. Plus 0.02 divided by 9.81 multiplied by 100. You'll get two percentages, add them, multiply the final answer by 1 over 2. That would be the total percentage uncertainty in t, and that would be your final answer. We will ignore all the coefficients. 2, pi, both will be ignored. Only the quantities that have the units will be, their percentages will be added. Okay, in many of the questions, the percentages are given already. So for example, I'm not finding the absolute, we are finding the same one percentage, but let's say the percentages are given already. Many times that happens. So let's say length equals to, I'll change the values this time. Length equals to, for example, 13.0 plus minus 0.8%. G is given as 10.5 plus minus 2.0%. You simply need to find the percentage uncertainty in time period. Now you don't need to find the percentages independently because the percentages are given already. All you do is simply add them and multiply whatever the exponent is. So 0.2, 0.8 plus 2.0, add it and multiply it by the exponent in the formula. Now this one will be something like this: 2.8 multiplied by 1 over 2. So half of 2.8 would be like 1.4%. So this is a percentage uncertainty already. Okay, let's say now the follow-up question is, or the question in the first place was, find absolute uncertainty of t. And I'll use this percentage. The question was never to find the percentage. The question was to find absolute uncertainty of t. So what do you do then? For absolute uncertainty, you were first supposed to find the percentage uncertainty. So did we find the percentage uncertainty of t? Yes, we did. Let's use this data, 1.4. And now you also need to find the absolute value or the principal value of t. How? Inserting the values in the formula. 2 pi square root L, which is, let's say this one was given in centimeter, this one was in meter per second. When you're finding the principal value, unit conversion needs to be done. Very important thing. Many of the students forget this. For principal value, units need to be converted. So 13.0 would be 0.13 divided by 10.5. And then you write it on the calculator as it is. If I write it quickly, square root, the length is 0.13 divided by 10.5. This is 0.698 or 0.70. Then 2SF 0.70 seconds. Now the final step is find 1.4% of your principal value. So 0.70 multiply 1.4 divided by 100. So this one multiply by 1.4 divided by 100, I get 0.0097, which in 1 SF, because absolute uncertainty has to be in 1 SF. So 0.01 seconds. Now there could be plenty of variations, but the basic concept remains the same. Obviously right now we cannot go through all the variations, but we'll go through most of the topics quickly. Okay, then we have the next important topic from this chapter, which is base units. For base units, you might be asked to find base units of a certain quantity from any formula, and that formula you might be seeing for the first time, but it doesn't make any difference. If you need to find the units of, let's say, k, make k the subject first. Once you have made it the subject, insert the units of all quantities that have the units. If something has no units, ignore it. And some of the units you should memorize all the time. It should be there in your mind: force, pressure, work slash energy, because they have same, and power. These four are the base. Like, if you memorize these, most of the question you'll be able to solve in very less amount of time. Force is always kgms minus 2. Work, power, energy is kgm2s minus 2. How? Because kg is force into distance. If you multiply this thing by distance, which is meters, so you automatically get kgm2. Power would be work over time. So this thing further divided by second would be s minus 3. And pressure would be kgm minus 1 s minus 2, because pressure is basically force divided by area. S minus 2 as it is, this m1, m minus 2 downstairs finally would be m minus 1. So whatever formula is given, make that thing the subject and insert the units of all the quantities in the expression. Normally they give you density also. So for density also kgm minus 3. That should also be memorized, density. So it should be these, not basically fantastic 4 but fantastic 5 in this case. If you need to show the equation is homogeneous, very important concept. For homogeneity of an equation, the units, base units on left side should be equal to the base units on the right side. So whatever you have on the equation on left side, find and solve their base units. Solve means simplify. And solve and simplify the units on the right side. If they are same, equation is homogeneous. If you need to find unknown power, for finding any unknown power, make the unknown thing the subject, and then add units on both sides. Make the units of the bases same, or bases should be same. And once the bases are same, for example on left side you have ms minus 1 raised to the power 2, and on the right side you have ms minus 1 raised to the power n. Or let's say the unknown is on left side, the subject, and on the right side you have raised to the power 2. Once the bases are same, you can equate the exponents and you can simply say the unknown exponent is 2. The last important thing of first chapter is vectors. So in order to combine the vectors, for example, one of the vector is here, let's say 100 meter. Another vector is over here, which is, let's say, 120 meters. Okay, now these Two vectors could be anything. Could be the velocities of the airplane and the wind. Could be any situation, or could be distance in this case. So velocity, the unit could be meter per second. So the vectors could be anything. Could be forces also in Newton. And let's say the angle between them is given 60 degrees. You need to find the resultant. Or sometimes you need to draw the resultant also. So if this is your starting point, the second vector has to be placed at the end of the first one. Over here, it is already placed like this. If the second vector was placed, let's say, someplace over here, then you need to place it properly. It should be over here. So it should be placed at the end of the first one. And then that was your starting point, and this is your end point. Finally, you draw a line from start point to the end point. That is your resultant vector. How do you find it? Either you can find through scale drawing. You can say 100 meter per second equals to, let's say, 2 centimeter. 120 meter per second would be, for example, 2.2 centimeter. And then, or you can use trigonometry. For example, this side C could be equal to, using cosine rule, a square plus b square minus 2ab cos of the included angle between the two given sides. Then you take square root. And if you need to find the angle with the horizontal, this is the angle with the horizontal. If you need to find the angle with the vertical, then the angle with the vertical would be this one. So you can find the angle with the horizontal, and then you can subtract from 90. So for this angle, let's say the inner one, you can use sine rule, which is sine A over A equals to sine B over B. So you can call this one A, this one you can call B, and this one would be side C. Then this angle would be angle B, and this angle would be angle A, and this angle would be angle C. So if this is the side small c, the angle opposite to the side is capital C. This is basic trigonometry, I mean. So for all the questions, like, I know the chapter is quite lengthy, so we'll have to just go through some of the important pointers. For all the questions related to graphs, so usually the questions are advanced. So if you're provided with displacement time graph, then the gradient of that graph gives you velocity. The velocity could be positive, could also be negative. If gradient is positive, velocity will be positive. Gradient is negative, the velocity would be negative. So for example, they ask you, this is the displacement time graph, and they ask you to find velocity at a specific instant of time, which is slightly the advanced variation. For example, this is 5 seconds. They ask you find the displacement at 5 seconds. Draw a tangent. So once you have drawn the tangent, choose any two easy points. Easy means the ones for which you can find the coordinates very easily. So one coordinate over here and one easy coordinate over here, and then you can use the formula of gradient, which is y2 minus y1 over x2 minus x1, and that velocity will be equal to gradient, and gradient equals to y2 minus y1 over x2 minus x1. So let's say this is x1, y1, and the coordinates are x2, y2. If you are provided instead with velocity time graph, and you then need to find the acceleration, then simply the gradient of that graph will be acceleration. And likewise, the acceleration could be positive, negative. So if this is a velocity time graph and you simply find the gradient of this graph at a specific instant, then you will be getting acceleration at that point. So in your syllabus, the graph could be either straight lines or they could be curves. So the straight line graphs have constant gradients. So for example, a graph looks something like this. If it is, for example, let's say displacement time graph, what does that mean? It means velocity is constant. If it is, let's say, velocity time graph, it means acceleration is constant. If acceleration is constant, then resultant force is also constant. If it is variable, for example, if it is, the graph is something like this. So this curve represents gradient increases. And if it is, let's say, displacement time, it means velocity increases. So whatever happens to gradient happens to velocity if you have displacement time graph. But let's say now you have a curve that looks something like this. And this is velocity time graph. So what happens to gradient? Gradient is decreased because the curve is getting more and more horizontal. So acceleration is being decreased. The resultant force is also being decreased. If you have the curves upside down, for example like this, and this is once again velocity time graph. In this case, your velocity is being decreased and the gradient is also being decreased. So gradient is being decreased and the acceleration, which in this case we call deceleration because the velocity is being decreased, the deceleration is also being decreased. And if you have a situation like this, so if we take a look at this graph, the gradient is being, sorry, first of all, the velocity is being decreased. Okay, for example, the velocity here was 5, and then over here probably 4, over here probably 3. Velocity is being decreased. What about the gradient? Gradient is being increased because initially the line was, or the curve was more of horizontal, and now the curve is more of vertical. So it means gradient is being increased. It means acceleration is also being increased. The acceleration in this case is deceleration. So the vehicle is slowing down, but it's slowing down faster and faster. The rate at which it's slowing down, that rate increases. So first it could be 10 meter per second. After every second, first it was 9, then 5, and then 0, let's say. So in the first second the change was only 1, then the change was 4, and then the change is 5. Other than graphs, The next important thing in this chapter is equations. Their derivation is very important. This one is directly from the definition of acceleration, or you can drive graphically also. You can say initial speed was u, final speed is v, and it took, let's say, t seconds to increase the velocity from u to v. The gradient will be equal to the acceleration. Another equation is s equals to ut plus 1 over 2 at square, and then you have v square equals to u square plus 2as. Then you have another one, s equals to u plus v divided by 2 multiplied by time. So these equations of motion can be used to find any of the quantity. For example, displacement of a vehicle after this much of time. So which one of these equations will be used depends on the data. Yeah, the most important thing is in A levels, many of times, especially if you have a question of 2 marks, 3 marks, 4 marks, you might have to use a combination of these equations. So probably you'll need to find the value of t using this equation, and then you need to find the final velocity using this one. So totally possible that you'll have to use two equations for a single question. Totally possible. If the equations have to be used for free fall, v equals to u plus at, s equals to ut plus 1 over 2 at square. I'll just skip the last one equation. So if you have to use these for free fall, or for projectile motion, if you have to use these equations for vertical motion, free fall, vertical motion, acceleration will be used as minus 9.81 always. Whether you're going up, whether you're going down, would be minus 9.81. This is the vector convention, vector sign convention. G would be minus 9.81. If you are, let's say, an object was thrown from a platform, from a cliff, it goes up the hill. So cliff is your, let's say, reference point. This is your reference point. If the object was above the reference point, the value of displacement should be taken as positive. Or if, let's say, another person over here, he drops an object from this height, the object goes down the cliff, probably in the water, with the distance of let's say the distance is given 10 meters. This displacement will be taken as negative. So below the reference point negative, above the reference point positive, and the direction of velocity is, if the object is moving upward, velocity will be positive irrespective of the position. If it's above or below, velocity will be positive upward, velocity will be negative downward. So positive upward, negative downward. This is how we use for free fall. Then projectile motion. The simplest thing about projectile motion is, whenever you see a question of projectile motion, you solve the question in two different ways, or the question need to be resolved or divided into two different motions. One of them is horizontal and the other one is vertical. So for example, if you need to find the maximum height reached, or what is the time to reach the maximum height, in these kind of situation you need to use the vertical motion, this side. For horizontal motion, for example, you need to find, for example, an object is thrown from a cliff, is projected horizontally, which is very important case. An object is projected horizontally and it goes towards the ground like this. Very important case. This will be broken down into two motions, horizontal. If you need to find anything related to horizontal, for example, they ask you what is a horizontal displacement covered. For horizontal motion, there is only one equation. Displacement equals to initial speed into time. S equals to ut. In horizontal motion, v remains same. So initial velocity, final velocity, horizontal wise remains same. If the horizontal velocity at the start is, let's say, 10 meter per second, everywhere during the projectile motion, it will remain 10 meter per second. So 10 meter per second here, 10 meter per second here, 10 meter per second just before hitting the ground also. So for horizontal, we have only one thing. We can't do anything else. For vertical motion, you have three equations. V equals to u plus at. Then you have S equals to ut plus 1 over 2 at square. And then you have v square equals to u square plus 2as. All the equations of motion. Why? Because vertically it accelerates. Horizontally it doesn't accelerate because the velocity is assumed to be uniform in horizontal motion. Now one thing is same, which is time. So time in horizontal motion and in vertical motion is same. It is very much possible that, let's say, you need to find this distance. Okay, let's suppose you need to find this distance, the horizontal displacement covered by the, let's say, projectile that goes to the ground. The height is given as 10 meters. Okay, let's just assume. Since we need to find the horizontal displacement, I should be using this equation. S equals to V, and I know the horizontal velocity also. So I should be quickly inserting the values, which is 10 into, all of a sudden I realize I don't have the value of t. Time now will be calculated through the vertical. Then we'll borrow the time from the vertical and we'll use that time for horizontal because time is same in both. So I'll use probably this one. S means the vertical. Now we're discussing the vertical thing only. Vertical displacement is 10. Technically below the reference, so minus 10. U represent initial velocity, but which one? Vertical. Everything here is vertical. There was no initial vertical velocity because the object is launched horizontally. So U is 0. 0 into t would be 0. 1 over 2 as it is. G, I told you, should be minus 9.81. T square as it is. And then you can easily, you can cancel out negative, negative, and t square will be 10 into 2 divided by 9.81. And then you take square root, get a value of t, let's say whatever it was. Then you insert that value of t over here. And that should be your horizontal displacement, 10 because the object goes below the reference point. You see, I told you over here, if the object goes below the reference point, displacement will be negative. This is a proper sign convention. I know many of the questions you can solve. You take it positive and then you take G also positive, but those methods, they have limitations. The proper method is, if the object goes below the reference, displacement is negative, but G would always be negative, or acceleration would always be negative. From this topic, the moment of force, that simply equals to force, the product of force and perpendicular distance from the pivot. That's it. Product of force and perpendicular distance from the pivot. In many of the questions, you are given with plenty of forces, you are given with plenty of distances, and in many times, especially in A levels here, the force may not be perpendicular to displacement. So for example, one force is here, another force over here, another force over here, another force over here. Let me draw on this side. The question is, the object is in equilibrium, find the value of the force F. This is, I assume, 10 Newton. This one we assume 20 Newton. This one we assume, let's say, 30 Newton. Diagram is not on scale. The object is balanced in equilibrium. And all the distances are given. Let's say it's a uniform meter rule. So the center point would be exactly at 50. And many of the distance you'll have to find mathematically. I mean, if certain part is given, then you can add or subtract accordingly. It should be depending on the situation. So let's say this one is from the pivot is 40 centimeter. This one from the pivot is, let's just assume, 20 centimeter. This one from the pivot is 15 centimeter. And the force from the pivot is, the point of application of force is, let's just say, 60 centimeter. Find the value of F. Problem is, force F, the force F is not perpendicular to the distance from the pivot. So what do we do instead? We'll resolve this force into components. One component would be here, one component of this force would be here, and let's say the angle was given as, the angle of this force was given as 30. Now this component would be F cos 30, and this component would be F sin 30. For moment, we only need the component of force that is perpendicular to displacement from the pivot. So we need only F sin theta. So the diagram now looks something like this. So just imagine the last force is F sin 30. What do you do then? Mark all the forces that rotated clockwise and mark all the forces that rotated anti-clockwise. This is a pivot. Assume you're holding it from here. So this one would be anti-clockwise. This one would be clockwise. You need to visualize this because this one would move over here. This one would move it this way. So need to visualize the motion. And this one would be anti-clockwise. And this one would be anti-clockwise as well. If the object is in equilibrium, then the moment of force should be applicable. The formula should be applicable, which is 30 into 40 plus, what is the other one, anti-clockwise? This one, 10 into 15, another anti-clockwise, f sine 30. Sine 30 is, by the way, 0.5. So 0.5 f into 60 equals to, what is the clockwise? 20. 20 into 40. You can rearrange it and find the value of f. So it'll just be the question of mathematics. For the torque, let's say you have pair of forces. The two forces should be equal in magnitude, opposite in direction, and they must not be passing through the same point. They should be passing through different points. Let's say the distance between them is 2, and both the forces are, let's say, 10 Newton. So 10 Newton, 10 Newton, this one is 2 centimeter. Find the torque produced by these couple of forces. How do you find it? Simply take one value of force, should be same, multiply by distance between them, which would be 20 Newton centimeter. But if you have to convert it into meters, you'll do it by yourself. Principle of moment. For an object in equilibrium, it's a very important definition for 2 marks. For an object in equilibrium, the sum of clockwise moments is equal to the sum of anti-clockwise moments about a point. So 3 things. For an object in equilibrium, first thing, then sum of clockwise and sum of anti-clockwise. This is the easiest part, most of the students write, but the last part is about a point. This is how we define principle of moment. Conditions of equilibrium. Sum of forces, or you can say no resultant force in any direction, and no resultant moment of force about any point. These are the 2 conditions for equilibrium. Usually you get a question for 2 marks. State the conditions of equilibrium. About the Newton's laws and forces. In any of the question, if you have a situation where the object is in equilibrium, it means sum of the forces in any direction should be 0. The equilibrium means no acceleration, or they can also say no resultant force, or they can also say the object is balanced, the object is stationary, the object is static. All of that means the object is in equilibrium, and you need to find anything, then put the forces equal to each other. So for example, you have a situation like this. Weight is given as 100 Newton, and the angle of the 2 tensions is just same 30 degrees. The question is, find the value of T equal to each other. So upward forces, sum of the upward forces should be equal to the sum of the downward forces. That's it. Sum of the upward forces should be equal to the sum of the downward forces. Now what is the sum of upward forces? You don't see any upward force, so that's why you need components. So one component of T over here, one over here. One component of the other tension over here, one over there. So this one would be the one connected with the given angle would be cos, and this one would also be cos. This one would be sine. This one would also be sine. Now what is the sum of the upward forces? There are two upward forces now. T cos 30 plus T cos 30, which would be 2T cos 30. So I write here 2T cos 30 equals to the downward force. We have only one downward force, which is 100 Newton. From there you can find the value of the force tension. So T will simply be equal to 100 divided by 2 into cos 30. If in any question they give you the thing that the object is accelerating, the acceleration is there, or the forces are unbalanced, or the object is having a resultant force, primarily the object accelerates, it means you'll have to use the very first equation should be F resultant equals to ma. Just write it every time you see that there is acceleration, the forces are unbalanced, there is resultant force, then write F resultant equals to ma. So for example, you have a block that is known as inclined plane, and an object is placed on the inclined plane, which looks something like this, and the forces are unbalanced. Let's say it is given in the question that the object accelerates down the slope. The given angle theta is, let's say, 30 degrees. The object is moving down the slope, accelerating down the slope, and so the friction would be up the slope. Let's say this is not a smooth surface, this is a rough surface, so the friction is up the slope, and yeah, this one would be friction. The weight is vertically downwards, which is mg, and for inclined plane you always draw two components of weight, one down the slope and the other one perpendicular to the slope. So this one would be mg sine 30, and this one would be, because this angle and this angle are equal, we prove these two angles equal to each other, but we don't have time for that. So you need to simply memorize this, that the component of weight down the slope would be mg sine of the angle, and perpendicular to the slope would be mg cos. But since the object is accelerating, so let's say I need to find, mass is also given 5 kilograms, and acceleration is also given as, let's say, 0.4 meter per second square. So let's just assume we need to find, okay, so let's say the acceleration is also given, you need to find the friction. Now since you see the acceleration, the very first thing that you do is write F resultant equals to ma. That's it. First write this thing. Now find out what is the resultant force. The resultant force along the slope, okay, because you need to find the acceleration is along the slope, so resultant force is also along the slope. The resultant force would be bigger force minus the smaller force. So mg sine theta minus, what is the smaller force? Friction. And that equals to ma. You insert all the values here and you will easily get the value of the friction. So for example, 5 into 9.81 into sine 30 minus the friction as it is equals to m, which is 5, into a, which is 0.4. All you need to do is to make friction the subject, and you will be getting the value of the friction. So I repeat, every time in the question of forces you see the object is accelerating, which could be given directly or indirectly, but you see the object is accelerating in the direction of the acceleration, apply the formula F resultant equals to ma, and you will be able to find any unknown quantity using this one.